Alright, so today we're going to be simplifying expressions using problem-solving strategies, and this is another way of saying they're going to be word problems or application problems. Alright, so just a quick reminder, we've been simplifying expressions for a couple days now, and we've been combining like terms, we've been using the distributive property. So today you can expect that we'll use both of those skill sets in order to answer these questions. Okay? Alright, so this first problem says, what is the perimeter P of the quadrilateral in terms of A? So the quadrilateral is this shape. Remember, it's just a four-sided shape, and we want to find perimeter. Okay? So we have to remember that perimeter is the sum of the sides. So we want to add all these sides up. Okay? So we're going to add all the sides. So we just write that down. 2A minus 8, that's my first side, plus A minus 1 plus A plus 3 plus 3A minus 3. Okay. So that's the situation. What is the perimeter P of the quadrilateral in terms of A? So now we have P equals, okay. Alright, let me scroll up just a little bit so we can get a little more space there. Alright, so we're looking for our like terms. So we have here our A terms, and then we have our numbers, and anytime you have numbers without variables, they are like terms. Okay, so we're just going to do that arithmetic. So that's going to be 2 plus the understood 1 plus 1 more. So 2 plus 1 is 3, plus 1 is 4, and then 3 more, 4 plus 3 is 7. So that's going to be 7A. Then we have negative 8 minus 1, so that'd be negative 9, plus 3 is negative 6, minus 3 is back to negative 9. So we could write plus negative 9, but mathematicians, remember, lazy, we're going to write one symbol, so minus 9. So P is equal to 7A minus 9. Okay. All right, let's take a look at another example here. What is the perimeter P of the triangle in terms of X? All right, so we're perimeter, we add up the sides. It's a triangle. There's 3 sides. So we would have X minus 1 plus 2X minus 1 plus X plus 3. We look for our like terms. So the understood 1 plus 2 is 3, 3 plus 1 is 4. That would be 4x minus 1, or negative 1, minus 1 is negative 2, plus 3 is positive 1. So the perimeter P is 4x plus 1. Okay. All right. Okay, so the length of a rectangle is 4x plus 7, and the width is 2x minus 3. What is the perimeter P of the rectangle in terms of x? Okay, so here it might be easier if we kind of sketch a little picture since they didn't provide one. So we just have a rectangle whose length is 4x plus 7 and whose width is 2x minus 3. Okay, so if we think about this, well, what do we know about a rectangle? We know that opposite sides are equal, so we could write in over here that 2x minus 3, and then this would be the other opposite side, so 4x plus 7. Okay. So we'd have all 4 sides, and then it would be just like the other problems where we can write P equals and we add them all up. But we know that 2x minus 3 is the same on both of those, so we have 2 of those, so we could actually say that we have 2x minus 3's. And then we're going to add that to our 2 4x plus 7's. Okay. And that will allow us to use our distributive property to say that we'd have 4x minus 6 plus 2 times 4x, 2 times 7, that would be 8x plus 14. and then 4 plus 8 is 12x, negative 6 plus 14 is positive 8. So that P would equal 12x plus 8. Okay, so question 4, what is the area A of the rectangle in terms of B? Okay, so first we consult our formula chart, and it says that the area of a rectangle, well, it doesn't actually have rectangle, it has a parallelogram, is B times H, which is base times height. On a parallelogram, that's going to be the base, which would be any side, and then the height is the perpendicular distance from one side to the other. Okay, we're not going to worry about that because on a rectangle, the base and the height are the two different length sides. So we can call this the height because it's the distance between the two sides, and this the base. Okay, we could also call this the base and this the height. It's really up to you. Okay, so we're going to fill in our formula. A equals B, which is 4B minus 1, and then H, which is 2B. Okay, so to simplify this, we notice that we have parentheses, and when we had a term outside the parentheses, we use distributive property. Okay, so we're going to distribute that 2B to both terms in the parentheses, so we get 8B squared minus 2B. So the area is 8B squared minus 2B. Okay, here's another example of applying the simplifying expressions. So what is the area A of the circle in terms of pi? Okay, so we consult our formula chart, and area of a circle is found by multiplying pi times the radius squared. Okay, so we look over here at our circle, and the distance from the center to the edge, right, is the radius. So R is going to be 3x. So we replace in our formula A equals pi, and then we have 3x squared. So we look at that, and we go back to our order of operations and following along. So this is multiplication, but first we have exponents. Okay, so I'm just going to kind of expand this notation. We have pi, we have 3x squared means 3x times 3x, and we know that 3 times 3 is 9, and x times x, well, that's going to be x squared. So I now have pi times 9x squared. Okay, but mathematicians would say that looks weird to write it that way, because they always like to put the Arabic numerals first. Okay, and even though pi is a value, they would write it second, because it's a value, but it looks like a variable, so they write it second, and then we would write the x squared, because it said to leave in terms of pi, so that means pi must be present in our answer. Okay.